Here we go again, guys. So in this video I'm going to show you how to create this nuclear explosion with tyFlow's Zenith fluid GPU solver. So this simulation was retimed. It was 4 times faster, so now it's 4 times slower, and it's captured from the 3ds Max viewport using tyPreview. And along the way I'm going to show you the most important options that you're going to need for this setup and for other setups as well. And also I'm going to draw a comparison between Zenith and Phoenix. So in this live, I've only written 2 fluid dynamics software, so I can go in depth about only those 2, sorry. And let's go. First, I'm going to create a tyFlow node, open the editor, and I'm going to create birth Inferno, like this. So by default, it's active. If I play the timeline, it starts caching, but it simulates nothing because we need to add emitters. So I'm gonna go into the Inferno emitter node. Let me just shrink this so we have more space to view the viewport. And for an emitter, I'm gonna go with a classical sphere. Like this, pick it. I could have also used that selected, now I see it. And now, when I play it, there's a simulation. So yeah, first difference between Phoenix and this is that Phoenix used to cache files onto your hard disk or SSD or whatever your storage device was. It created cache files for each of the timeline frames. So unlike this, Zenith uses RAM caching by default. So all of the data from the simulation, it goes into your CPU RAM right here. And it's used for displaying the preview. Let me just play it a little more so it becomes more interesting. Yeah, here it is. And that's faster. So you can see that the simulation is running a bit faster than in Phoenix. Now that I scroll back, it's going to start playing frames from the RAM cache. If I just reset it, it's going to start simulating again. So if I just jump to frame 75, it's going to simulate all the frames from 0 to 75. And right here, you can see the progress of the simulation. So let me just reset it again, jump to the end of the timeline. Ah, we had the tooltip. No, you evil tooltips. Why did you appear in the middle? All right, let's reset it again. Let's jump here. 60, 70, 90%. Okay, here it is. So you can see the simulation progress. Showing it once more. Here it is. So if you just jump to a certain frame, it's going to simulate all the frames between 0 and this point. Or the other way to simulate would be just to, again, reset it and just play the timeline. So this way you could see the progress of the simulation and how it unfolds. And if anything is wrong, you can take action. So in order for me to play the timeline like this, I need to disable real time here. I better do it so it would show you each of the timeline frames without skipping, because with different resolutions it's gonna it might start skipping stuff and it might look weird, especially if one frame takes longer to simulate. Then it's gonna have already advanced to a much distant frame on the timeline. So you better disable real-time playback when you want to play the timeline like this. There is a difference in performance between these 2 approaches. So let's clear it again. If I jump straight here, it's going to calculate all of the frames up to this point and then display the last frame in the preview. If I play all of the frames, it's going to be a bit slower because it's not only going to simulate each of them, but then it's going to create the preview data and upload it for the preview on each simulation step. So that's going to be a bit slower. Beware, because if you use larger simulations than that, it's going to it's going to take more time. Now there is an even faster way, which is probably the one that you're never going to use, but I'm still gonna show it because I find it amusing. So if I just clear the cache right here, and if I just disable the Inferno recall node, I can just skip here and it's going to be fast as hell. So probably not gonna notice much difference, but let's make the timeline 300 frames long. Refresh, skip here. Here it is. Otherwise, if I enable the Inferno recall, skip here, it's a bit slower. So the difference is that if I disable Inferno Recall for the simulation, if I go here, it's going to simulate all the frames, but it's not a cache anything. So you're going to view the end state of the simulation. It's going to go through all of the processing in order to get the final frame, but in between, you still have this frame showing because there is no data. So yeah, in case you want to only view the final result and just make sure that at the end of the simulation there is something, you can also use this approach. It's going to be faster, but yeah, not very applicable to real life. Let's shrink the timeline. How to view the stats for the simulation. So right here, I've shrunk this because I want to see the simulation progress, but let me just open the listener window. Let me just clear everything because I don't want it to get messed up. Yeah. Clear the cache, go here. All right, yeah, let's clear this again. Simulate one frame. So here it is, 45 sparse cubes, 1.47 million sparse voxels. So this one is 1.5 million voxels. Not that big of a simulation. So let me make the timeline like 1,000 frames, and let's play that thing. So it continues simulating, continues. If I play the next frame, now it's 6 million voxels. So yeah, that's the speed. It's a bit faster than Phoenix. You can see that yeah, some people call this like real time, but there are different definitions for real time. So for example, is it real time if you have it at 100 frames per second or 10 frames per second, because the difference is tenfold. So let's just call it interactive, because you can do other stuff. You don't have to when you run the simulation, you don't have time to go buy a car and mortgage your house and come back and it still hasn't finished yet. So let's call it interactive. So you can iterate fast. You can do trial and error quickly. One other thing that is also important to mention is that now the simulation runs on GPU. So unlike Phoenix, which used CPU, and in the very last moments I started adding some of the simulation stages to run on the GPU. So for example, the conservation, which is the slowest, the most important conservation stage, I added some CUDA support there, but I didn't even optimize it. I just did something, and on some GPUs it's actually faster than the CPU. But I didn't go into I didn't go too far because I didn't have time to finish it, because circumstances struck. And Phoenix simulates mainly on CPU. Zenith simulates entirely on GPU. So except that like 3ds Max runs on CPU. So the CPU data has to go to the GPU, and then interesting stuff starts happening. So with GPUs, also there is another thing, that you need an NVIDIA CUDA supporting GPU. The solver runs only on CUDA. So that's the kind of hardware that you need. And there is one important thing that happened, I think it was in November 2023, when since then all of the latest NVIDIA drivers have this default behavior that if you run out of GPU RAM while you simulate, so here I'm using a 4090, I have 24 gigabytes of RAM. If I fill up all of my GPU RAM, it starts spilling into CPU memory. So it won't crash. Yeah, hopefully I've done a decent job of handling eventual errors, but it should continue. But since it spilling into CPU memory means that it's going to compute something, and then it's going to move it to CPU memory. Then it's going to take the next piece of CPU memory, put it on the GPU, compute, bring it back to the CPU memory. This is going to be slow. And the simulation is going to be about 10-15 times slower. It's still going to run, but it's not going to be very efficient. So you have to you have to be aware of how much GPU memory your simulation is using. That's going to depend on how many frames you're simulating, and if your GPU memory starts running out, you have to take action. We can go into more details about this and the management of your RAM cache in other videos. I'm just, if you're interested, yeah, please let me know, and I will do a dedicated video about this with more information. But in short, you have to keep an eye on your GPU memory, you have to keep an eye on your CPU memory. The simulation will probably survive if you run out of memory. We did all that we could so that whenever there's a problem, it would allow you to save your scene and not lose work, which is very annoying when it happens. So I hope that you would have less of this kind of experience. But you have to be aware of how much your memory your simulation is running, so that you could make the educated choice between how to use your RAM cache, whether to save stuff to files, so the Phoenix Aura files are out of bounds. The Aura is a proprietary format of chaos. I don't have the code. I haven't seen it in over 2 years, so it's out of the question. What we can do is to save to VDBs. So you could save VDB files. Caching is gonna be slower, but you would be able to then replay stuff that doesn't fit your memory in case you're doing huge simulations. Also, saving to VDB files is gonna allow you to export data out of 3ds Max to other software. And right now, VDB files are the only way to talk to renderers. So if you want to render this thing, in order to render it with V-Ray, R-Node, Redshift, you have to export VDB files and then load them into the respective node of that renderer. So for example, with V-Ray, you need the V-Ray volume grid. You need to load the VDBs there, and then it would be able to render them together with the other stuff. We're still waiting for support from the other renderers. Eventually, over time, this is going to happen so that you would be able to see your Zenith simulation in the viewport and just one click render it out. Hopefully these days are coming soon. So yeah, that's pretty much it. Let's get to simulating nuclear explosions. So I'm gonna shorten my timeline, just play it back again. That's how it looks. So another important difference is between Zenith and Phoenix that I just have to mention is that Zenith is sparse. So here from the Inferno display, I can show the sparse cubes, and the simulation is only happening inside of these boxes here. So here they are coalesced into one big blob, but actually they can take any configuration that you would like. Unlike Phoenix, where the simulation only could happen inside of a box-shaped simulator. I'm gonna make the box display as box so that we can have more box for our viewport. And let me center it. So for example, this simulation here is not that bad when it's put into a box. But there is still some empty space, and the empty space takes up RAM. It also might take more or less computing power, so the code tries to skip empty space, but still it's not as if it doesn't exist at all. And this could make the simulation slow, and this could make the simulation use much more RAM than you actually need to spend on it. But with sparse simulations, like in Zenith, you can have the simulation take any shape. So for example, a very bad scenario for dense simulations like in Phoenix is a rocket launch. So you're going to have smoke spilling out right and left, and then you're going to have the jet moving upwards with the rocket nozzles, and this is gonna form a T-shaped simulation where if you want to put this inside a box, you're gonna end up with a lot of empty space like here and here, which is gonna take up RAM and processing power. So with Zenith, this is no longer a problem. So as the grid expands, so Phoenix adaptive grid expands by just growing the box. So the box just becomes bigger. It expands left and right and up, and you know the other directions. And with Zenith, more of these sparse cubes get added wherever interesting stuff happens. So all of this should happen automatically. There are still controls for the adaptive grid right here in the BERT Inferno, you have adaptive grid, and here are the thresholds. So this means that if the velocity somewhere is above 0.5 meters per second, as it reaches the ends of the grid, it's going to create more cubes. So you can change this threshold, and if you increase it, it's gonna need more velocity to expand the grid. So the grid is gonna expand less. So let me actually show you how this works. So now we have this fire. I'm gonna tell it to use 1 meter. Oh, let me just remove this imaginary box from here. So it doesn't do anything because it's not added automatically to the Inferno operators. So this was not enough. Let's make it have 2 meters of velocity in order to expand. Let's make it use 3 meters per second. Let's reset, restart. Right, let's make it use how many? 10 meters. Is that gonna work? Or 100? Oh, wait. So yeah, what I'm doing is stupid. So I had to disable the other channels because it's still gonna expand whenever any density, any temperature, any fuel. So yeah, here you can see the errors live. So luckily, when I do an error like this, it's not gonna take me hours to figure out because the simulation is running fast. But okay, here it is. So with 100 meters, it just clips the simulation. It refuses to expand. It's only gonna use those boxes that are initially created around the emitter. So yeah, let me drop it to 10. Any change? No. So I went too far. Let me drop it to 2. How it's gonna work with 2? And now, since so now initially it clips, but then as it continues gathering speed, it manages to break through, and so it's only clipped for a while, but as the temperature is hot, it tries to move upwards and it manages to break through. If I disable this, it stops expanding again. So I can tell it to expand around any density. So you could have a different combination of channels, of grid channels in your simulation. So you could have also fuel, temperature, and you could choose around which of those channels the simulation is going to expand and which of them it's going to ignore, or which of them is going to be harder to expand around. So if you want the adaptive grid to be more sensitive and expand more easily around stuff, you need to lower the threshold. So this means that even when there is 0.00001 of density nearing the grid, it's gonna create more cubes around it so that no density ever gets clipped. And the same for velocity. So the velocity exists even further around the visible simulation. So it creates a field that moves upwards in this simulation, for example. So if you want it to be more sensitive around the velocity, you could just again use a very, very small number like that, and it's going to expand around velocity where it's even the slightest of movement is detected. So yeah, it looks pretty close to what was in Phoenix, but yeah, hopefully it's also intuitive and it's better this way. So I'm just gonna re-enable everything. I'm gonna disable some of that stuff in case I decide that I don't need it. I forgot what the default value. Okay, yeah, I managed to I managed to hit them. So yeah, I think that I already said once that we're going to go back to the nuclear explosion. So now let's go back to the nuclear explosion for real. I'm not gonna take any more tangents like this until we get something going. So first, let me just make sure that everything is using like round values. So let me put it at 0, 0, 0, yeah, 10 meters in radius. Let me hide those boxes, those sparse cubes. Let me simulate it. So this doesn't look like a nuclear explosion quite a bit at the moment. One important thing before we start, man, I said that we're gonna start, but yeah, I promise that we're really gonna start now. So just let's go to the unit setup. Just like in Phoenix, this is very important, so let's not get it wrong. I'm using emitters. That's how I view stuff. So this is just how I display stuff. We're going to be making a very big explosion, which is going to be hundreds of meters long. So I don't want to be using centimeters or millimeters here, because I don't want to be dealing with 6-digit numbers or something like that, or very small fractions either. So I'm just going to set it for, just view it as what makes sense for this setup. I'm going to use 1 unit equals 1 meters. Let's go to the Bird Inferno. I'm just going to make it simple. Voxel size is going to be 1 meter. So 1 meter is 1 voxel. Just start as simple as that. So now it doesn't look a nuclear explosion. It looks like a burning sphere. So the first thing that I'm going to do is I'm going to turn the smoke way down. I'm gonna use this magic value. This is just the value that I used in the scene that I showed you. It's not quite round, but if you use that, it's gonna look like my simulation. So now I'm gonna lower the density. I'm not gonna completely disable it, because the sphere is going to be the emitter for our nuclear explosion. So this is going to be the explosive device. So that's the reason why it's spherical, because it needs to be symmetrical. We are going after a simulation that has a lot of symmetry in it. We don't want it to just blow over the place and become a mess. So it needs to be neat and tidy nuclear explosion without much side effects like that. So the density is going to be it's not going to be exactly 0, because that's going to be like the material that gets vaporized with the actual nuclear device. So that's going to be the casing and basically the actual nuclear bomb. So I'm not going to set it to 0 completely. Temperature remains 6 by default, as by default, and I'm gonna make it behave like an actual blast. What? I'm gonna make it a blast. So let's emit only for the 2 first frames of the simulation. Let's play this. All right, so let's emit the nuclear simulation in 2 frames and then stop. So in other cases, if this was a bit longer, I would have set it in seconds, so that if I have to do some change to the timeline, change the frames per second and stuff, I don't have to adjust it anymore, so it would automatically adjust. But for this explosion, I just empirically determined that emitting for 2 frames works the best. So I'm gonna set it to just frame 0, frame 1, and not touch it anymore. I'm going to make it look like an explosion by emitting pressure. So it's gonna blow up, and then it's gonna start rising, and then it fades out because it cools off. I'm also going to disable the motion velocity. So here the other velocity stuff, I can talk about this in more detail. Let me know if you need videos about that. There's most probably going to be a video about this, because it's a big topic. I'm not going to go into much detail, but the motion velocity is kind of like the thing that you had in Phoenix sources. It just transfers the velocity of moving emitters into the simulation. So this says that if this sphere is moving, 85% of its velocity are going to affect the simulation. So if you set it to 1, this means that it's going to entirely copy its velocity into the simulator. Is going to force it to move with the moving emitter. So that's useful even if the emitter is not moving. So if the sphere is static, if I set its motion velocity to multiplier to 1, this means that 100% of its velocity is going to get imprinted into the simulator. So it's going to imprint 0 velocity, and it's going to force it onto the simulator. So this means that this sphere is going to act like an obstacle. So whenever you need an obstacle, you just need to enable motion velocity, set it to 1. That's going to tell the simulator that the velocity in these voxels is not going to allow it to get touched by anything. They are going to stay that way. If anything tries to blow through them, it's gonna hit a wall. It's not gonna pass. So in this case, though, I just want this to be transparent to the simulation. I don't want it to obstruct it. I don't want it to block it. I don't want this to be an obstacle. So I'm gonna disable motion velocity, and we're gonna talk about this in the future. So just leaving pressure on, and I'm also gonna use the replace mode. So by default, the mode for all of the channels and the velocity is absolute maximum. So just the bigger the stuff that gets emitted, this mode is important when you have overlapping emitters. Let's start by this. If your emitters overlap, this mode is going to decide what happens. Hello, it's the emergency fact checker service. This guy was lying to you. So the emitter mode is not only important when you have overlapping emitters, but it determines what happens when the emitter emits into the solver. So if the underlying voxels already contain some temperature or some velocity or some fuel or some density, it says how the new values are going to combine with the others. If the source is going to replace the old values, no matter if they are created by another source from a previous node in the event, or if they existed already in the previous frames. So let's continue. So their values could get added, they could get interpolated, they could, or each emitter could replace whatever is already existing. And the order of emission is in the order that you place them here in the event. So in order to make sure that nothing suspicious happens, I'm just going to set it to replace. Abs max, which is the default mode, means that the bigger the value, just the bigger absolute value is going to win. So for example, if in this place of the simulation you have temperature of 5 and some emitter comes and says, let's set this temperature to 10, 10 is going to win out. And abs, so this is for the maximum part, so the maximum thing is going to win out. Abs means that the absolute value is going to win out. So if you have negative stuff, so for example, if you have negative temperature, if the temperature here is, for example, minus 0.1 and another emitter comes with a temperature and says that this temperature is going to be -1, -1 is going to win. So the biggest value, the most distance value from 0 is going to win out. So yeah, we just determined that this works better for the general case, but especially for the Nuke, I'm going to set it to replace. So this means that whatever existed under here is going to be forced to a pressure of 150 and this density and this temperature, and nothing is going to change that. So and this is only going to happen for the first 2 frames. After this emitter disappears, it doesn't work, doesn't do anything anymore. I wonder if I should make this sphere transparent, but yeah, it looks okay now. So another thing that's not very visible in this setup, so if I want to show off, I'm not going to be able to show off, but yeah, let's try it. But yeah, it's not going to be very impressive. It's not going to be very impressive in this setup. Is that now finally stuff that is immersed into the simulator is just rendered properly. So before that, in Phoenix, if you have a box, a simulator box, it's either in front of everything or it's behind everything. So now you can finally have stuff in the viewport immersed into the simulation and they're gonna blend properly. Hooray! It was about time, just like 15 years later. Okay, so the next thing that I wanna change, and I'm just looking at my notes, I'm gonna increase the pressure to 450. So that's going to make a bigger explosion. So if I even set it to like 1000, boom, it's going to create an even bigger explosion. But there is something that, oh wait, let's not explode that much. One more thing that I wanted to change was that right here, you pick what part of the emitter emits what is emitted. So by default, you emit from the triangles. You can emit from points, or these could be the vertices. So if I place some complex geometry, I can only emit from the vertices. I can emit from the triangles, or I can emit from the volume of this geometry if it has a volume. So if it's a plane, it doesn't have a volume. It will still emit just like if it was emitting from its triangles. Also, yeah, that's important to mention that in Phoenix, if you had a broken geometry, so when you imported some model that had holes in it, like duplicating vertices, like stuff was overlapping, and the software had a hard time figuring out what the volume of the thing was. So for example, or you could even take a box and just delete one of its sides. It won't have a volume anymore. Now it's going to become an open geometry. And if you did that in Phoenix, it would create very sad times for Phoenix and for yourself. So you're both gonna end up just getting weird results. And to make it more interesting, it was just sometimes. So sometimes the solver could overcome this and just walk out with dignity from this situation and just continue emitting as if everything is okay. But if it was rotated a certain way, or just if the stars aligned, it might work well, but just some little changes might make the voxelization blow up. So now in Zenith, even if the geometry is broken, it should be able to live with it. So in theory, no, not that I'm challenging you, but in theory, whatever you throw at the solver is gonna be voxelized properly. So even if it's open, it would try to fill up what you perceive to be the volume of the open object. So if you take like a cracked eggshell, it's gonna fill half of it with the stuff that you're emitting from the emitter. So I think that this was important to mention. So in this simulation, I'm emitting from the triangles, but I'm using a very high thickness. So that's basically making the emitter larger. So if I make it like this, it's going to be just a sphere. If I make it like this, it's going to be smaller. So I'm using it, the radius of the sphere is 10, and I'm telling it to use a thickness of 15 meters. And I could go with a larger sphere. Hello, sphere. Here it is. So I could go with a larger sphere, and I could just use the volume mode. But that's just the way that I set up the scene. So this original scene was very old. It was before I implemented the volume voxelization. So that was the way that it worked back then. Sorry about this. In volume mode, it should work. So let's actually try volume mode. Yeah, it works. So if I reduce the thickness, it's going to emit from the entire volume of the scene, of the emitter, of the sphere. But yeah, in this case, I'm using triangles and I'm using a very, very high thickness. So it's going to work like this. And the thickness works in both directions. So it expands the emitter and also it works inwards. So since this scene has a radius, this sphere, it's a sphere, not a scene. The sphere is not a scene. So if this sphere has a radius of 10 meters and you dial up the emission thickness of 15 meters, that means the entire volume of the scene is going to get filled up anyway. So yeah, I hope that this makes sense, guys. Sorry for the over-the-top explanation here. So now we have a larger sphere. Don't die yet. I have more time until the end of the tutorial. So here is how the sphere emits now. So it's more fiery, not that smoky, because yeah, the smoke is quite thin, but yeah, that's how the thing works now. And let me just check out my notes. So this emitter is ready. Is it ready? 450 meters, yes. Now, this doesn't work very good yet. So first off, the temperature cools off way more quickly. So let's go into the Inferno, the birth Inferno, and most of the simulation options are here. They're in the birth node. So let's go here to the temperature and turn off the cooling entirely. I don't want it to cool off. I don't want to lose ambient temperature. I want it to be hot and stay hot longer. All right, so I want it to blow up and start rising. So that's going to be the base of our nuclear explosion. Blow up, start rising. There is also this other thing. Let me just take these timeline enlargement pills and let it run longer. Right, so it starts rising. At this point it rises too much. So I want the scene to actually behave as if it is even bigger than it's at the moment. So right here I have the simulation scale. So this option is pretty much the same thing that was in Phoenix as well. So if you set up the scene in a certain way, and then you don't want to start resizing your emitters and your obstacles and all of the interacting stuff, you can just make the solver believe that the scene is on a different scale. So I'm gonna make the simulation scale 0.1. Like this, and now we're at 70%. I'm gonna just change the scale. Again, that's the value that I used in the original scene. We're at 80%. Let's see the difference, how it's gonna look when I made the simulation scale smaller. 96, 97. So the simulation gets slower towards the end because now it has more voxels. Yeah. So now it's larger and it's reached even higher. So let me go back. Okay. So I'm gonna work in this scale. And that's what this option does. Also, you have time scale where you could make the simulation again slower or faster. So changing the simulation scale changes the temperature because the temperature rises when it's hot. When you make the simulation smaller, it is going to rise higher. So that's the logic behind this. And I have some other options. So here we have a temperature propagation. This is like the flux of the temperature. So this is also equivalent to like the dissipation of the density. So I don't want the temperature to dissipate. I'm gonna set this to 0. It's gonna take some time to reach frame 90. Alright, so I don't want to lose any temperature. I want everything to be as hot as possible. These defaults, they're good for other scenarios, but for the nuclear explosion, we need some special settings. So no cooling, no propagation. And also, here is a different option. So you know that in nature, when you heat stuff up, stuff expands, and when you cool stuff down, it shrinks. So as the simulation cools down, it shrinks. By default, there is no shrinkage. I'm gonna use shrinkage of 200. So now it's gonna compress a little. It's not gonna get so bloated like right now. Or would it? Whoops. No, don't go so far away. Yeah, I'm gonna look into this. Gotta make sure that it works properly, so not gonna talk more about it. So just gonna dial this value and I'm gonna check it later. Well, of course it's not gonna shrink. I already set the cooling to 0, so the cooling shrinkage should do nothing. It's okay. It's okay. Hold on. So yeah, now we have this explosion. So it blows up, starts rising, and it's quite fiery. Very little smoke, and it doesn't dissipate anymore. So now I can start adding the second thing to the scene. So in most of the nuclear explosion setups that I did previously with Phoenix, I was using this kind of pattern, and I've used it for other setups. So I have this thing that is the ground. So I'm gonna have this box. I'm gonna make it like 3 meters. Whoops. Let's make it like, oh, 100 is not enough. Let's make it 300 meters wide. Let's just see how it looks in relation to the emitter. So now we have a Saturn configuration. I want to move it a bit. Oh, so now we still have a Saturn because of this grid. Okay, let's move it down, and I'm gonna make this also make it a box. Display as box. It's already a box, just display as one. Identify as box. And now I'm gonna also set it minus 20. Let's try this. And now I'm going to create another emitter because I want to use different settings. So if those same settings gonna apply, you can add more geometry here, but now I'm going to use different settings. So pick the plane, and by default it starts emitting temperature. That's not the desired result, so I wanted to emit only density, like this. And now you can see that the initial explosion actually penetrates through the ground. And now I'm gonna do some more stuff with the source. But here you can see that that's why I love the ground plane, because it creates all of that material that the nuclear explosions should actually start drawing in as it rises up. So the stem of the mushroom cloud is gonna get formed by this stuff. Also, let me make it, okay, let's not be modest, let's make it 500, let's make it 500 meters in both X and Y directions. Right, so you can also see that the mushroom cloud also changes, so it's the butterfly effect. Just little changes to the ground add up to changes elsewhere. All right, so that's our nuclear explosion at the moment. It doesn't look very convincing, so, but probably you have seen crappy nuclear explosions before. There is more stuff to do on this. So yeah, and also you can see that here it starts curling up the smoke. And yeah, you can also see the radius here is basically the radius of conservation. So you can see that the smoke further away doesn't get disturbed. Here you can see a very clear difference between this smoke, which gets drawn into the mushroom cloud. So if you want to increase this effect, you gotta increase the conservation, and I'm gonna do this because the nuclear explosions in particular, they need more conservation. So now its radius is 10 meters. It's yeah, it's figurative. It's not exactly 10 meters, but there's a radius where the velocity of something moving in the fluid simulation is gonna affect other velocities. So this option was called fluidity in Phoenix. Here it's conservation because it reflects the conservation of momentum. If I increase it, oops, let's not make it 300 right away, it's gonna make the simulation slower. So that's the important effect in terms of performance, but it's also going to propagate the velocity further. So let's make it 50. Propagate even more. And let's make it 100. So this way it's gonna also fall off more until the edges. Until it reaches the edges. Also, one other thing that I want to do, so here are some artifacts here, I'm going to also take care of them. One other thing that I must do, let's just enjoy this explosion for a second. Yeah, relaxing explosion. One other thing that I want to do is change the initial number of voxels around emitters. So it's that option. So I want to make it larger. So if I make it, let's proceed further. As the simulation processes emitters, it's going to create, let's make it 3. Oops, no, did I make it 4? No, come back. I can use the escape key. Oh yeah. Let's make it 3. As the simulation processes emitters, it's gonna create sparse voxels around them. And as they create their stuff, as they create their temperature and their density, the simulation is gonna expand and create more cubes around those cubes that already exist. And eventually, as important stuff leaves those cubes, it's gonna shrink. But when an emitter, like the sphere, starts blowing up on the first frame of the simulation doesn't know that it's gonna be a violent explosion. So we better tell the solver to create more cubes in advance around it so that it doesn't clip the fireball and the velocities created by it. So even if you don't see the actual fireball getting clipped in the beginning, it's gonna clip the velocities around it, which are also important, and it's gonna make them square. Square not, it's gonna confine them to a cubic shape, and this is gonna ruin the explosion a little more or less. So that's the other thing that I'm gonna do. I'm just gonna add more cubes. Initially it adds one layer of cubes around emitters. I'm going to add 3 layers of cubes in the beginning so that we're sure that we're not losing any velocities. So even though that you don't see the velocities around the important stuff like the temperature and the smoke, the velocities are also important. And especially for nuclear explosions where you need to have that symmetry, they better not get squished and clipped. So I'm going to increase those initial cubes to 3. Now, there was something else that I needed to take care of before I proceeded. Now you can see that the explosion initially just goes through the bottom. Then it starts rises up. So I started telling you about the motion velocity and how it's going to turn stuff into obstacles. So here I have to do a few more changes. So the timing of the ground emitter, so this is the node that emits from the box. I'm going to use continuous timing, so it's going to emit throughout the simulation. It's going to insist that there is smoke there. So this smoke is going to represent the ground, the dust, and even the heavy stuff that the nuclear explosion lifts from the ground. It's going to emit throughout the simulation, so it's going to be continuous. This is by default, no need to make any changes there. It's going to emit from the triangles with an emission thickness of 1. I could actually make it emit from the volume. Yeah, so not much change in the final look. I think that in the original scene I was using triangles, so I'm gonna go with this. But yeah, it's more proper to use volume because I guess that in this case, oh, the height is -3. Interesting that this works. In this case, there is gonna be some empty space inside it, but yeah, I don't know. Okay, let's use the volume like it should. So it's not gonna produce the exact same per voxel result like in the video that I showed you, but that's a more proper way to do this. So I'm going to emit a lot of density. So density goes between 0 and 1. You can set it to higher values than that, but you usually don't need to. So you can also adjust this with the render settings. So I'm going to emit 1 volume, so it's completely opaque. And I'm going to set the motion velocity to 1. But even as I do this, it's still gonna continue to penetrate through the ground. And that's because I need to set the emission mode to replace. So what happens here is that the sphere blows up, it creates those velocities, it creates that stuff, and then the ground just says that it's gonna create its own velocity only if it's higher than the already existing one. So I'm gonna set this to replace, like this. So because the initial sphere is large, it still manages to pop out, so I'm gonna just move the ground plane a little, like this. Yeah, otherwise it's gonna so there is this thing that, let me just disable the pressure in order to show you. So that's the size of the initial sphere. So previously we had the ground plane maybe something like this, so a little part of the sphere penetrated through it, and then when we added pressure, it started exploding at the top. Not so much pressure contained in this little piece here, so it just added a bit more, but yeah, it's penetrating because the initial size of the sphere was penetrating the ground. So that's why I'm gonna move the ground a little downwards, and basically the distance between the ground and the sphere is gonna be a big factor for the shape of your nuclear explosion. So if they're closer, one thing would happen. If they are more distant, another thing would happen. The size of the sphere is going to change things a lot. So I reached the conclusion that like this kind of configuration works best. Let's see how it behaves. Right, so initially it expands a lot. Then it starts rising up and drawing stuff in. So there is one more important change to the solver options that I'm gonna use. Let me just let's leave the simulation. Let's let it run a little more so that I could show you what is bothering me about this setup. So not only that is just a pillar of flame, so which doesn't look like a proper nuclear explosion, but also it's not very symmetric. One way to make your simulation symmetric is, and also probably the most important one, is to go here in the advanced settings and look at the trace velocity option. So by default, advection traces the velocity through the velocity field by just curving wherever there is curved velocity. And when this value is not 0, it means the length of the tracing step in voxels. So 0.95 means 95% of the voxel length. If it's more than 1, then it's gonna start skipping voxels. So you better keep it below 1 in order to get better accuracy. The lower that you set it, the slower the advection would be. So beware of this. Thank you. So this makes the simulation more precise. It should be more accurate, more believable, more realistic. But also, since it reads more stuff from the velocity field, it adds some more noise. They call it numerical dissipation. So if you want to decrease this effect, I'm going to turn off tracing the velocity entirely, just set it to 0. Setting it to 0 is going to make stuff in the simulation, oh man, so now we're going to wait a bit. Setting it to 0 is going to make the simulation more symmetric. There is going to be less of that noise introduced. So if you want to do stuff like this nuclear explosion or just other effect that needs to be symmetric, set this to 0. So this way it's gonna keep its shape better. There are still some things poking from here and there, but overall you can see that here it's keeping the shape better. So not tracing the velocity has a few problems. So for example, the velocity could entirely pass through an obstacle. So if you think that something is contained within an obstacle like this, which has its motion velocity set to 1, high velocities could just jump through it and never understand that there was an obstacle in their way. So that's one thing to watch out. But otherwise it's going to help keep things more symmetric. But here things are not that symmetric because we have other things to also consider. I'm going to zero the vorticity right now. By default it was 0.95. If I zero the vorticity, things are going to get as symmetrical as they could be, given that there is still some butterfly effect and some stuff that runs away. But now this is going to be the most symmetric thing. Okay, let's not swear into this. I might be forgetting something, but this is going to get very symmetric. So you can see that right here we have this like very fine mushroom stem. And these are two very important settings for the nuclear explosion. But we don't want to have absolutely no vorticity. We want to have a bit more detail. So I'm going to set this to 0.45. Just want to find the balance between too much asymmetry and too little detail. So you can play with this. Also, just if you don't like this shape, there is again some butterfly effect involved in everything. If you don't like this shape, try just adding 1000. You would get something that is much different. Is it gonna be much different? Now let me see if I'm gonna eat my words. Yeah, so now it's more square. So you can just get different variations by just pushing this or any other contributing factor, just like the distance between the sphere and the ground and this kind of stuff. So you can get a different shape by just changing those values. Let me just double check if everything is... okay, so here is one more important thing. So far, I was using the PCG. I was not using the PCG conservation, I was using just the default conservation. It's faster, but for the nuclear explosion, I want to use PCG. So it creates a better rolling for the smoke, for the vortices. When you're doing explosions, when you're doing stuff that is not... Okay, so you can see that the difference is just huge. When you're doing stuff that depends on just drawing the smoke more and just rolling better, PCG is the right choice. So now this explosion in the beginning, and you can see how it's starting to draw stuff from the ground much differently than the other conservation. And now it's gonna rise in a different shape, and you can see how much it did stir up the stuff at the bottom. Wait, so did I accidentally enable this? Let me just move the tyPhlow icon out of this mess here. All right, let's see how the explosion looks now. Now you can see that also thanks to PCG, the symmetry is also a bit better. And now the shape is really starting to look like the thing that we want. The shading still needs a lot of work, but I'm gonna leave this for last. But now the shape is starting to look properly. And you can also see that here all the stuff that was near the initial explosion is also getting stirred up. And just the way that the simulation works just automatically creates that effect. So if you don't want to be using particle systems to just stir the smoke up towards the bottom, you can just count on the natural behavior of Zenith to get that effect. All right, so how does it work in the beginning? Does it manage to penetrate a little? Okay, so let me just show you the difference now. Now I know that I need to move the ground further down. Let's move it like this. Oh, how many times did I move it? I should have typed it. Okay, 32. Now we're going to see the difference between having the emitter close to the ground and further away from it. So now we're going to get a very different simulation. And that's one way for you to get different kind of mushroom shapes. Just regulate the distance between the emitter and the ground. Or just again, shrinking the emitter, making it larger. So now you can see that these veils start to form underneath the mushroom cloud. And like with actual mushroom clouds, these effects really are a matter of just butterfly effects. So sometimes you're gonna get those, sometimes you're not. And it's just, it would be a bit of a trial and error process in order for you to get the shape that you really like, unless you wanna force it in some way. But right here, I'm just going to be showing you the natural, no, cancel, I don't want to go to frame 300, no, oh, thank God the escape works. No, am I simulating again? How many clicks did it manage to cache? Damn, okay. So that's the nuclear explosion that we have right now, and that's close to the final result. So let me just double check the settings, so I make sure that I've typed everything from from my notes. So we have voxel size 1, conservation at 100, vorticity the vorticity in the video that I showed you initially was 0.4 to 1 because I was playing with it in order to get more variation. Simulation scale 0.1. Thankfully, tyFlow covers all of the fields that are different from the default. Trace velocity disabled. Maybe we should add a checkbox here so that it's more explicit. 3 voxels around emitters at the first moment where they emit. PCG conservation. So for the adaptive grid, one thing that I did, let me just check how many boxes we have at that particular moment. Okay, so one thing that is very important for nuclear explosions, and if you want to get better rolling of the smoke around the simulation, is to give the solver just more room. Yeah, this is going to eat up RAM. This is going to take time to process. This is going to heat up your CPU. You're going to change the atmosphere of the planet. But if you allow more empty cubes around the explosion, it would allow it to swirl better. It would not clip the velocity. It would make it more symmetric near the end. So if I disable the sparse cubes right here and go and shrink the adaptive grid. So first I'm gonna, now the temperature and the density in this simulation overlap a lot. So I'm just gonna turn off temperature. I'm gonna turn off fuel because we don't use fuel. Not really sure why I wanna do this. It's just my OCD that drives me to do that kind of things. So sorry about that. Oh man, it's at 50%. I should have scrolled a bit more to the left. Now, thankfully, simulation here is gonna complete at some point. So this is a video that I wanted to make for 10 years. I have a few very old video files of my first attempt at this tutorial, and it took me days before I could show all of the different iterations. So thank goodness that we reached the future. Cool, yeah, so I disabled this. I will disable the fuel as well. It should not make any difference in the final result, but let's see. It's going to be interesting. If I manage to break something, that means that I'm going to be able to fix something that would have broken for somebody else. Something kind of like changed here, so I'm going to scroll through the video later and identify stuff that I did not expect and just verify if everything is okay. So what I did for the scene from the video was I also let me just double check my notes. I have the minimum velocity set to 0.6, so this is going to shrink the empty voxels around the explosion a bit, and it's going to lose some of that symmetry. This is going to help you keep more stuff in your VRAM. So let me see. So right now we're using 8 gigabytes out of the 24. So if we go to the later stages of the simulation where the mushroom cloud has risen higher, it's going to start eating up more of your GPU RAM. So that's a trade-off that you might be willing to make if you don't have enough memory. So you could allow the adaptive grid to shrink more. You're going to lose some of the symmetry in a nuke. Maybe you don't care about this if you're doing a different kind of simulation, but you could shrink it here. Increasing the threshold value will shrink the simulation. It's going to need a higher value in order to expand the grid. Let me just double check. My smoke was 0.01. Yeah, it's by default. So that's the only change that I did to the adaptive grid. Let me just double check the sparse cubes. Yeah, the sparse cubes are a little tighter around the simulation. So here you can see that the brighter ones are the ones that actually contain any visible data. The darker ones are those that are not going to be shown in the preview. Cool. So these are the settings that I used for the simulation. I also have to double check the settings for the emitters so that I am not missing anything important. 15 meters, 0.011, 450 pressure, Replace mode is very important. Replace mode for the other emitter. Actually, now, since this is the first one that emits, you could use apps max here, but yeah, if you want to be sure, because it's gonna, in the second frame of emission, it emits for 2 frames. In the second frame, it's gonna meet some stuff underneath that was already emitted, and if that stuff is higher than what the source is trying to emit, it's gonna ignore it. So this is gonna cause some asymmetry. So better keep replace for both emitters. Wait, don't want to rename it. I think that these are all the simulation options. And now we can, yeah, again, we can change the shape by just moving. If I move the simulator 33 meters underground, if I move the ground 33 meters underground below the source, actually, now we're gonna get a different result. Hopefully it's not too ugly. And after that, we can start moving to the render settings, or the actual viewport display settings. 93, 94, 95. All right, so this made it much different. So let me move it up. Let me move it back to 32 meters. I don't want that kind of fat shape for the explosion. I might also reduce the vorticity a bit. I don't want this much noise in the stem of the mushroom, but let's see. Once I dial the render settings in, we might go back to the simulation, because now that stuff happens fast, we don't have to wait for hours to get our final result. Come on, 97, 98. Yeah, that's much more tidy. I have these extra stuff here appearing. Let me try one final attempt. I forgot the value that I used before, so here's the risk of just dragging stuff in the viewport and not being able to dial in the exact thing. Or let me try 31. What's gonna happen then? Is this gonna work better? Let's see, a bit of trial and error here. Just gotta be able to iterate and see results. It could be faster if I scroll to an earlier frame, but since I want to compare these frames, I'm just gonna stay here, in case we get something like the fat explosion that we got at -33. I don't want to miss it. I think that everything's fine. Well, maybe the previous one was... Let's try 32.2. Those trails underneath the vortex ring were looking better at 32. Simulating. I gotta also check the number of voxels. Yeah, okay, so we have some of the veils, we have the rough shape of the mushroom cloud. I don't know if okay, let me try one final thing. So I'm gonna bring this threshold back to 0.5. This is gonna help the symmetry a bit. I swore to make a symmetric nuclear explosion, so let's strive towards that. This should help the symmetry a little, although the RAM is gonna decrease. The free RAM is gonna decrease, the used RAM is gonna increase. 94, 95, how is it gonna be? Well, that's more symmetric. Okay, so now I want to get rid of these like random fiery things underneath. So let's just check the dynamics. Also, so in order not to simulate accidentally up to frame 300, let's just shrink the timeline and let's play it in case there is anything ugly. So that's also good that we get the shadow on the ground. All right, so at this point it's very symmetric. The second mushroom cap starts forming here. Now it's starting to get to lose some shape. Starting to get more scrambled. Oh no. Stop it. No. Alright, so that's gonna be our final shape. Unless it's not. We could always do more changes, but let's call this a day for now. Let's not drag it out any longer. So let's go to Inferno Display. Display Inferno. So here there are different modes. So you can only look at the ambient occlusion. So we have some fast ambient occlusion for the viewport, or you can check only the color, the density. Like these are kind of the render channel, the AOVs. Now we have also the velocity in normal format, but that's not, yeah, the normal shading is not the shading of the normals. Yeah, and also you can see the cubes that contain interesting stuff in them. So gonna stick to normal shading. That's the actual final look. So let's just tweak the fire curve first. So I'm gonna hold on. No, did I delete the, what did I do? I pressed delete and deleted something important. Did I delete the ground plane? Yeah, let's reset it again. I forgot how to delete the markers on the render curve. So actually, yeah, in order to not get that slow preview, let's just, okay, oh, let's wait for it. Not gonna cache it. Not gonna need to cache it more after this. 80%. How's the RAM? So here I went over 50%, and yeah, actually now I'm at 50% RAM. Okay, delete marker, yeah. No, let me just deselect everything in the viewport. Okay, so that I don't delete anything accidentally. Just select it, delete it, select it, delete it. Sorry if you guys know a better way for me to do this. Is there a marker here? Yeah, so I can delete this one as well. So here is the temperature. Here is the color of the coldest parts of the temperature. So it's gonna surround everything and it's gonna glow, but you have cold temperature all around the warm temperature, the warm temperature core. So if I set this to black and then I change the warm temperature, now you can see that the inner part of the explosion starts glowing. So the colors that I used for my original explosion were a bit more yellow for the higher temperatures, a bit more red for the low temperatures, something like this. So here it's also important to get the range of the value. So we know that the minimum is 0, the maximum is 6, because I used 6 in the emitter here, there, here. So the maximum is gonna be 6, but if I want to stretch it a little, I can do this. So by just changing these ranges, change where the actual curve starts and ends. So yeah, this is also looking interesting. So you can see a lot of interesting details here. And yeah, so the maximum is gonna just change where the actual color shift begins happening. So the value that I used for my scene was 3 because I wanted to be bright. I wanted to cut out some of those temperature pieces here. I just wanted to isolate them and remove them from rendering. So if I lower this to 0, we're gonna include all of them. If I increase this, the more that I raise it, the less of those pieces we're gonna see. So in the final scene that I showed you, I was using a very small value for this, but probably this is gonna come into play later. I'm also gonna reduce the intensity a little. Yeah, it didn't help much, but yeah, it's pretty self-explanatory. I'm not gonna go into much detail here, but yeah, increasing the density is gonna make it it's gonna make it brighter. In the end, I used 10, and here I'm just gonna use a linear preset. Not gonna change it. Exponent of 1.1. So yeah, again, changing this is gonna blow it out. I think that initially when I started tweaking it, I set both of these to 1, and then I started experimenting. So if you lower this, again, you can quickly see the changes. So these are going to be more visible as I change the other options here. So the thing that I want to do is make it look more fiery, like more explosion-like. So the first thing that I need to do in order to do this is to enable the temperature blur. So by default it has some temperature blur. I can even zero it, so now the temperature is the sharpest. And as I increase it, the temperature gets blurred. Now you can see that it's blurry. And this doesn't look very good right off the bat. So the value that I ended up using in the end was 50. So now the temperature has blurred up, is blurred out so much that yeah, it just looks blurry. So it's nothing special. So the thing is that the temperature blur plays really well with higher smoke density. So if I start making the smoke thicker, now the temperature blur is gonna start showing some interesting stuff. And I'm not afraid to make the smoke in this scene thicker, so let's continue. Let's make it thicker and thicker, and now you can see some interesting stuff starting happening. So now that extra detailed, like that, the crispy chicken shader starts popping out. So in the end, I was using 1.8, and now you can see that this looks much more explosion-like than without. Now let's compare the actual temperature blur disabled. That's the raw temperature. Not very interesting, kind of like the Phoenix shader. Now, as I increase the temperature blur, the magic starts happening. And now you can see that these hot creases here start appearing. So in the end, I was using temperature blur of 50. So why did I go with 50? I wanted to use the hot creases shader. It's the crease masking. Here it is. So when I enable it, by default, in this scene, there isn't much of a difference, but those two options are the depth of the creases and the width of the creases. So I want them to be wider. I want the depth to be higher. Let me just increase those values a little. Here they are. Here the hot creases start appearing. So if I move back a little, these creases, they are based on the places where the smoke actually forms some cracks in the surface. So yeah, here if I lower these, the depth is 0, so the creases are just everywhere. If I start increasing it, the places where they appear, they reduce, and these options, they also play with the ambient occlusion. So I'm gonna they use the ambient occlusion map in order to create their thing. So I'm gonna raise the quality of the ambient occlusion, just I'm gonna increase the distance. Let's actually even show you how it works in the ambient occlusion. Okay, yeah, so it's not very visible. Let's keep it this way then. I'm gonna increase the ambient occlusion distance so that its quality is higher, but this is gonna make it slower in the preview. So the more that I increase it, the more these cracks in the plume, the better they look. So the idea is to go as low as possible without looking terrible. So I might use, well, it was good with 8. Yeah, it was good with 9. 8 is also okay. So I'm gonna stick with 8. I used 6 for the previous scene that I showed you in the beginning of the video. So let's see how these things work together. And now, yeah, I can control the depth of these creases. I can control the width, so they can be just here in some places. So the end goal is to have those be visible, to be as irregular as possible, just not be the same everywhere, just have them here and there, and just, yeah, to make it as diverse as possible, just to have them appear in different places with just the different shapes and different density. So this is the interesting why there are these artifacts at the beginning. Could be because of the initial shape. I gotta look into those as well. So now that's how the, whoops, let's use Z. Oh, this Z pause the simulation. So that's how these work now. And that's the shader work that I'm after. Let's just double check if everything is okay here. I want the fire of the explosion to look like, whoops, to look like this. Let me just, yeah, if I change the depth even more, because, yeah, I was using 4.5. Let me stick to 3 because now it allows, yeah, it shows a bit more interesting colors here. The width that I ended up with was 88. Okay, yeah, so with more width, they start covering more of the explosion. With less width, they look more like cracks or rivers through the shape. So it has to be something in the middle. Maybe this. How does it work? How does it look in earlier frames? Well, I think that it looks fine. Yeah, it seems fine to me. So I'm gonna keep this look. And the other things that I did was that I increased the strength of the ambient occlusion in the viewport. So right now there is some ambient occlusion. Maybe you can see it right here. In the darker parts you can see some shapes. The idea of the ambient occlusion is to serve like a dome white, so to have more details pop out even when they are in shadow, just not make it black and white. So I'm gonna go, I'm gonna go to the illumination sub rollout, and from here I can increase the strength of the ambient occlusion. So I can overcook it like this, so that everything that is shadow still gets a lot more detail visible. So here I can actually, yeah, now that I've overcooked it, I can show you how the distance actually looks. So if I lower the distance, it starts getting flatter, so more of the stuff disappears. If I raise it, it's gonna get slower, but it's going to have more midtones. And I forgot what distance I used originally. Was it 8? Yeah, it was 8 meters. So in the end I was using ambient occlusion of 4.25. What else? And the final thing, yeah, the last things that I did regarding the look of the explosion were using the glow. So now we can barely see it because I've reduced the temperature so much. But the glow especially helps the nuclear explosions. Just, yeah, let's just enjoy this curling, this rolling of the smoke a little. I'm also gonna have to simulate a little more. Yeah, let's try scaling the glow right now. So first off, now since we have temperature up to 6, I'm gonna disable the clamping. So yeah, this makes it slightly brighter. Yeah, the threshold is the parts of the simulation that actually generate the glow. So if I lower the threshold to 0, even the bright smoke is gonna start generating glow. So it has to be something in the middle. Let me just actually increase the intensity first. Let me boost it so that we can see it, or would we be able to see it? Let me just double check if I have everything. Yeah. Yeah, here we are. Right, so I can boost the intensity from here. I'll decrease the scale. So the final values that I used were 0 and 0.25. I wonder what was different, because now I'm getting very... Oh, is the threshold fall off? Now I'm getting very different results, so maybe I just have to eyeball it and then see what was actually the difference between... Maybe I forgot some setting. But yeah, I just overcooked the glow. Yeah, so this way, only this top portion of the explosion is shining. So I can change the threshold in this way. So if I increase it, it's gonna start glowing only from those two places. If I decrease it, 0.4, everything is gonna start shining, even the smoke. So I want to have it somewhere in the middle, and yeah, the threshold fall off. That's important. I wonder why I'm gonna lower the intensity now. Yeah, so now this is gonna make it... Yeah, I overcooked it. So I want this to be higher, so that it's not taking the shapes of the cubes. Otherwise you can just see it jumping from one cube to the other. So I'm gonna scale it a lot. Yeah, now you can see that in the beginning it's very bright, so it's a nuclear flash, but then it's too much, so I might lower it. Yeah, if I lower it too much, the smoke also starts glowing, so it's not gonna be that. I'm gonna lower the fall off, and let's try a little less density. How does this look? So this flashes at the beginning, then it glows, but yeah, I want it to be a bit more visible. So probably because of the changes in the other render options, I also got these options got affected a lot. But yeah, what if I increase the scale and also increase the intensity, so that it's not focused around one part of the simulation, it gets more spread out. Yeah, maybe that's too much. not gonna be focusing that much on it because the explosion creases here are what I wanted to show you the most. Now here it's interesting that so now we have more diverse colors. I actually could even increase the intensity so that I could make the cracks brighter. It probably could fall into the category of artistic preference, but yeah. So not gonna yeah, so now it flashes, and yeah, I wonder how maybe now, because the cracks are mostly on the top, let me try decreasing the smoke opacity a little. So yeah, if I set it to 0.1.6, 1.5, these, let me turn off the glow now. Yeah, you can see that the cracks start washing out. So I better keep the opacity high. If I go too high, these cracks are gonna disappear entirely. So yeah, maybe something like between 175, 185. How does it look in earlier stages? That also looks good. Yeah, okay. So I think that right here, yeah, so that's why I had this value set that low. So that makes a lot of difference. Now it's much more interesting, and now the temperature is spreading out much lower. So that's the answer of the question. Now I don't want this to be set to 0 because I get these flashes of temperature right here. I don't want those, so I gotta increase it a little so that these disappear. I wanna cut them out of the rendering. The final value that I used was 0.03, and this is how it looked in the simulation that I did originally. So I gotta check those artifacts here. So now that the temperature is spreading more, now I gotta take care of those creases and make sure that they are not that uniform. Just I want to make them a bit more interesting. So now if I overcook them like that, that's not cool. This way they are just way too few. So maybe gonna raise it a bit like this, and yeah, just it's a two-dimensional control. What were the values that I used here? So I used depth of 4.5 in my original explosion, and the width was 0.2. So maybe that is, yeah, let's also try resetting the opacity to 0.8. Yeah, so now it's a bit more, yeah, or actually way too mellow. How does the opacity change this? Okay, so I'm gonna stay with 185 and yeah, increase the width. I want those to show up like this. I think that this makes it look more fiery. But again, yeah, these are just these are the controls to get the result that you're after. Maybe that, yeah, let's use 4.5. It's way too uniform here, so now I will probably reduce those. Should I reduce the opacity a little? Maybe, yeah. Should I increase the intensity? Yeah, I can. And also I can change the color, so I can make this like a bit wider, maybe not that much, but something like this. Yeah, so now in the beginning we have more white, not that much yellow. It's also more cloudy at this point. So yeah, basically these are the controls. I want those cracks to propagate a bit more. Let me just see. Yeah, it's not gonna be this way. So let me return this to 0.03. The temperature board is at 50. If I change the ambient occlusion now, it's also gonna affect it. So yeah, between 6 and 8, this looks a bit more interesting. And what were the creases masking settings that I used? 4.5, 0. Yeah, I don't want to burn it out like this. Don't want them to be too few. What if I set this to 10? Yeah, now this way they are going to be too wide. 6, 5, 4. Yeah, maybe something like this. And also, again, if I raise this, I can get rid of the temperature propagating way downwards. But maybe that's too much. Something in the middle. Maybe 1. Yeah, I can keep playing with this even more, but I'm gonna cut it short. Let me try even longer distance. Yeah. And now I don't have too much creases, so I'm gonna increase them. Yeah, so maybe that's gonna be the final look. Though this here is way too uniform, maybe, yeah, maybe we'll roll back on the distance. Didn't. Yeah, maybe actually this is the better way. Yeah, I'm gonna decrease the width and increase the depth. Balance the depth more. Yeah, okay, cut it off. That's it. Enable the glow again. Flashy at the beginning. Here the glow is a bit too much. Now the glow is distributed better, now that the temperature reaches the lower part. What were the final settings of the glow that I used? I used more scale, but yeah, I think that with less scale it was better, but I also used 0.25 intensity. Yeah. Also, the explosion looks better with this field of view. It looks like it's shot from a TV camera. Alright, and let's stick to this. I'm gonna increase the timeline a little, and now I'm gonna try to retime it. However, let's see how much memory I'm gonna have. Like in the video, I'm gonna try to yeah, that's a nice silhouette. I'm gonna try to slow it down 4 times. Right, the shape is good overall, nothing too disturbing. These cracks here are fine. Started spilling over to CPU RAM. So initially this is gonna spill over just a part of the RAM cache. So that memory usage here also includes the RAM cache by default. Let's go into the recall. So here we have the prefer VRAM option. Now let me clear this. Now as I simulate, at some point it's gonna say that the GPU memory for the cache has overflown, so it's gonna start transferring parts of the RAM cache to the regular RAM. So at this point you're not losing parts of the RAM cache, it's just gonna start transferring from GPU to CPU. So this means that I can still keep pushing it. But when my regular memory also fills up, so at this point the simulation is still with the same speed, the playback is gonna start getting slower because the RAM cache is gonna start moving to the CPU memory. Once the CPU memory fills up as well, then I'm gonna start losing the older frames of the timeline. So at that point, if I still have more simulation to do, I better switch from writing to the RAM cache to just adding, which one was it? Adding a VDB Inferno to VDB. No, it's not the. I mean the export Inferno node, which is gonna save VDB files to the storage. Right, so it looks like we're gonna successfully reach frame 200. Oh yeah, now I remember why memory is not a problem at the moment. So in order to do the retiming, I need to enable velocity for the RAM cache. So let's just reset it, clear all the memory, eventually close the browser, close 3ds Max, close Chrome, so that everything gets released. I'm gonna save this just in case things go south, and I'm gonna enable velocity now. I'm gonna cache the temperature. Actually, no, I don't. I think that's good. I'm gonna enable velocity. So I'm not going to enable emitter velocity. That one is needed when you want to retime moving emitters. So at this point, I'm just going to use the regular velocity, and that's going to save a bit of RAM. I'm also going to use the Velocity Strong compression. Now with Velocity Extreme, I might get even more space, so I could use that as well. But sometimes if you retime with this, you might get some artifacts, especially when you have fast moving stuff. So yeah, let's try it. Let's see, it might work for this setup. So yeah, let's just clear, cache it again. Just before doing the entire cache, let's just see if we're timing this. Oh, now it's illuminating the grid. Actually, I gotta turn it off, but okay, let me simulate a bit further until here probably, and let's try the retimer. I'm gonna scroll back to the beginning just in case, enable the retimer and retime by speed, and I'm gonna use 25% of the speed. So now with this, let me limit the timeline. I was simulated how many? Aha, I got 50 frames, so I should be good until frame 200. Let's play it. Let me just, okay, I need to use smooth retiming interpolation. Let's play it again. And here we have it retimed. Alright, so now this is gonna play at 25% play speed. Things are looking good. RAM usage is looking good. So I might eventually cache it until the end of the timeline. So now I know that it's 4 times slower, so caching up to frame 50 is gonna be enough to retime until frame 200. Now if I cache up to frame 200, I gotta extend the timeline to 800 frames, and I gotta check the RAM usage then. But yeah, so far things are looking promising. Let's pause this. The simulation looks good, and let's do that. I'm gonna turn off the retimer, cache until the end. Alright, so I think that this is as far as we can get. Otherwise, past this point, it starts getting really slow. So let's call it a day at 140 frames. And yeah, one day I gotta buy more RAM. Cool. So also, I think that I should lower the distance of the ambient occlusion, because it gets slower with a higher distance. So let's try this. Is this responsive? Oh, is it auto-saving? Alright, so let me, just in case, I'm gonna save it. I'm gonna restart max. Alright, so at this point I have restarted max to make sure that everything is clear. I'm caching it again. So the RAM cache has spilled over to the CPU cache. Here's frame 140, and now in order to retime it, I'm switching back to frame 0, enabling the retimer. Here it is. I'm gonna have to compute 140 4 times 280, 560, like this. And now I'm gonna create a tyPreview of the, actually, let me just show the save frames. I'm gonna make it custom 720 by, yeah, let's make it vertical like this. Yeah, so that I match the settings of the video that we started with. Okay, looks centered. Right, and let's do a tyPreview. Just let me double check if the retiming, we have smooth retiming interpolation, so it's gonna be retimed smoothly. And now I'm gonna run the tyPreview. Right, active time segment, percent of the shaded resolution. Let's go. Let's stop, play it, and see the final result. So in the meantime, I had the chance to just check the original video again. So it's not quite the same. In that one, I actually left much wider hot creases. But overall, this is the workflow. So thanks guys for watching, and see you in the next video. If you want to see something specific, please let me know. And cheers! Bye!